I'm Dean Stocker. I teach physics at the University of Cincinnati, Blue Ash College. But I'm on Christmas break now, so I'm not teaching physics. But I'm still immersed in it. When I play guitar, it's the tension and the mass and the length of the string that determines what note plays. And with that fire, it's converting chemical energy to light and heat. Now, I'd like my students to be able to think that way as well. We just finished a project that I hope will help them to do exactly that. The unit we did is called Physics is Everywhere. I hooked the students into the project with a pre-class survey, including the question, what is one way that you believe physics may be relevant to something that you do on a daily or weekly basis? Then I took the student responses and made a slideshow out of them. About 2 weeks into the term, this slideshow was running when they entered the room, and they did some brainstorming about things relevant to their lives and which they'd like to focus on while answering the question, how is physics related to something that I care about? Then I laid out the final project for the class, to create a presentation that clearly demonstrates the physical concepts behind some aspect or aspects of their chosen topics. They divided into groups based on their common interests and differing skill sets. Then each group started defining what it is about their topic that they would study, and developed questions that they would explore over the next several weeks. We used the engineering design process to learn related material and create the presentations. They'd already identified and defined the problem in the process of forming groups and creating guiding questions. Then they began to gather information through lessons in class and their own research, recording relevant information in their engineering notebooks. In one lesson, we identified alternatives for collecting data using cell phones, and we learned how to use a free software package called Tracker to analyze video. Students selected the method they felt would be most effective for collecting data and created a draft presentation to present to the class. These presentations were peer-reviewed, giving everyone an opportunity to see what others were working on and to find ways to improve their own presentation by retaking or reanalyzing data. And we did a lesson on how to choose the best type of graph to use to present information as clearly as possible. On the last day of class, the teams gave their final presentations, and all of us learned things from each other on that last day. In addition to just presenting about the application of physics to their topic, they also shared about the impact of these topics to society and about careers that are either related to their topic or that use the same sorts of data collection and analysis that the students themselves used. The unit seemed to go well, and I plan to do it again with my class next year. The students also seemed to appreciate it. In an end-of-term survey, 89% of them either agreed or strongly agreed that the unit was valuable for helping them to learn physics. And you can use these lessons too if you'd like. The resources for them are available on this wiki.